Alright, okay, in this video, I'm going to discuss another concept that you're going to transform the cumulative distribution function into a probability density function. Right, a cumulative distribution function into probability density function. There is a video that I make three video about how to moving from the probability density function or the small letter fx into a cumulative distribution function, capital Fx, by using integration, right? So the process of finding this is quite complicated, right? That you see before, right? I have teach you before. So by using the formula of negative infinity up to x, right? So now, if this is the way that you integrate, right? Then when you want to come back here, right? You have to differentiate, right? When you integrate, then you want to go back, you must differentiate, right? So when you differentiate, you want to go back, you must integrate. Right? So there is a concept of antiderivative, right? So okay, let's look at this. So I'm going to show you how to using this concept in finding back the small letter fx, right? The probability density function. We need to do differentiation. All right, okay, let's see. Alright, okay, let's see. We have to go interval by interval. That's the process. Right? It's just like the process when you're finding the cumulative distribution function, you have to go interval by interval. So it means that then we go to the first interval, right? So which is for x less than negative 2. So very simple. If you want to find the fx, the probability density function, this is cumulative, right? Then you have to differentiate the cumulative distribution function at that interval, right? Differentiate during that interval. During the interval is 0. Okay, doesn't matter. If you differentiate 0, right? If you're differentiating 0, you are still getting 0, right? So now, then we go interval by interval. There is a proper way of finding the cumulative, the density function. All right. Now for this interval, right? So your probability density function, you have to differentiate the fx here. So during the capital fx, the cumulative distribution function during this interval is 2 plus x over 10. All right, it's 2 plus x over 10. All right, it's actually differentiating. So 2 over 10 is 1 over 5, right? Plus with x over 10, right? 1 over 10x here. So it's simplified. 2 over 10, 1 over 5. 1 over 10x. So if you differentiate the constant, you're getting 0, right? So if you differentiate 1 over 10x, you are getting 1 over 10. Alright? So means that the probability density function at this interval will be 1 over 10. Alright, now go for the third interval. You go for the third interval. So when the interval x less than 2, right? So your probability density function at this moment will be you differentiate the fx, the cumulative fx during this interval, which will be x plus 1 over 5. I can rewrite this to be 1 over 5x plus with 1 over 5, right? It's the same, right? X plus 1 over 5, right? So differentiating 1 over 5x, you are getting 1 over 5. Differentiating 1 over 5, you have 0, right? You're getting 0. So okay, now we go for the fourth interval. You have to be hardworking, right, doing this. So now go for 2x less than 7. Okay, so now I have to differentiating the cumulative function during this interval, which is 3 over 5. And 3 over 5 is a constant, right? It's a constant. You're differentiating a constant, you are getting a 0, right? So and the fifth interval, so it will be 7x less than 15, right? So again, you have to differentiate the cumulative distribution function at this interval, which is x plus 5 over 20. You can rewrite to be 1 over 20x, right? X over 20 is 1 over 20x plus with 5 over 20 is 1 over 4. 1 over 4. So very simple differentiation skill. Differentiate 1 over 20x, you are getting 1 over 20. Differentiate 1 over 4, you're getting 0, right? So now you have up to the 5th interval, and now go for the 6th interval, the last interval. So the 6th interval, which will be, if you want to differentiate for x greater or equal 15, so your density function at this interval will be differentiating the cumulative function at this interval, which is 1. Differentiating a constant, you're getting 0. Okay, I have done all the 6 interval, right? Now, then later on, you need to summarize. You need to summarize this into a function, right? A function. So now this is a property density function, right? Try to observe all of this thing here. So then if you look at this, this is 0, right? 0, this is 0, and this is also 0. So there are 3 intervals which is not 0. Okay, the one that's 0, the one that's 0, 0, and 0, I try to put a cross first, because later on I will write back. Okay, look at this. Start with this interval, so it's negative 2x less than 0, right? In this interval. So your function at this interval for the property density function will be 1 over 10. So it's just 1 over 10. Alright? The one that got 0 later, right? Okay, now this one have done. So now this one 1 over 5, right? 1 over 5. 1 over 5 is at the interval of 0 up to 2. So you just write there. 0 up to 2, right? 0 up to 2. So now this one have done, right? 1 over 5 from 0 up to 2. Okay, done. Now go for this. This is 0 later. Okay, 1 over 20. 1 over 20. So it's during the interval from 7 up to 15. 15. Alright. So finally, you have write all the one that got value into the function, right? So this is 0, 0, and 0, right? I'm going to put them together, right? Do you remember? If you remember that a property density function, they will have a 0 at last here, which is otherwise. You have to write the otherwise, right? Otherwise means that other than this interval, and this interval, these 3 interval giving 0, right? We categorize the interval to be otherwise. So this is your probability density function by using differentiation, right? You must also, as a student, you must know that able to, from the small letter fx, which is probability density function, to transform into the capital letter fx cumulative distribution function, right? You have to go to see the video where I'm doing this, okay, from here to here. Now in this video, I talk about how to move from here back to the density function. All right, hope you understand this section here. Okay, now I'm going to discuss about how to finding the probability by using cumulative distribution function. All right, so I want to differentiate how to using the cumulative and using the density function. What's the difference between these two, so that you're not confused? All right, what's the difference between these two? How to find probability by using this, and what's the difference if you find probability by using this? Right, there is a difference. All right, let's see the difference between these two when we come to find probability. All right, you have to follow the video, cannot skip the video, right? Because everything that I talk here is very important. All right, you must differentiate between these two. All right, but I'm going to make a conclusion for you now. If you want to find the probability for any probability, all right, that the question requests, Sir, Mr. Tan really suggests that you using the cumulative, right? But if the question is already asking you to find the cumulative, right? If the question is already asking you to find the cumulative, then it's better for you to use the cumulative distribution function to finding the probability instead of using this. But if the, okay, listen to my advice here, but if the question does not require you to find the cumulative distribution function, if the question never asking you to find the cumulative distribution function, then you don't have to put so many effort in finding the cumulative distribution function. You're just using this. Right, so there is a difference. All right, so when you have this, then if you have cumulative and density, I definitely will using this. We were using this. But if there is only density without the cumulative, then I have to using this. Right? Okay. Hope you get what I mean. All right. So, okay. Let's say in this case here, if I want to find the probability, right? I want to find the probability of x less than maybe 8. Right? X less than 8. And remember, this is a continuous random variable. This, okay? So px less than 8 or px less or equal 8, they have the same meaning. Okay, same probability. All right. The equal or not equal is not important. All right. So, and if when I said px less than 8, it's actually f8. All right. Because fx, the capital Fx is defined to be probability of x less or equal x, right? It's a cumulative function. So when you say find probability of x less than 8, you can actually rewrite this as px less or equal 8 so that you can write in the form of capital letter F8. So very simple. So how to evaluate the probability for this interval here? So you can look at this. Okay, you can look at this. 8. 8 is between where? Not this, not this, not this. Yes, this 7, between 7 and 15. Then you have to put the value of 8 here. If you're using cumulative, then you just direct substitute. So you just take 8 plus 5 over with 20. So then you were getting 13 over 20. This is your probability. Alright, this is your probability. Very fast and very efficient if you're using cumulative. But okay, sir, Mr. Tan going to show you how to using this. You must know too. Alright, as a good student, I am mentioned to those that a good student, I should tell you that the probability of x, you have to compare, you have to know both, right? You have to know everything. So x less than 8, right? So it's the same as you have to do integration. The problem here is if you're using the probability density function, you have to use integration. That's all, right? Integration here. So where is 8? Then you have to see the value of 8 here. Where is 8? Right? 8 is here, right? 8 is here. Okay, 8 is between 7 and 15, right? So when you talk about px less than 8, that is very troublesome in this case here. So because you're going to integrate, because 7, 8, before 8, right? Less than 8. So you have to add up. You means that you have to take from -2 up to 0, 1 over 10 dx, right? Start from here because it's before x less than 8, right? So it means that you have to do integration from -2 up to 0, 1 over 10, all right? Plus with, continue again from 0 up to 2, 0 up to 2. So during this time is 1 over 5 dx, and later on you have to plus with, okay, start with here 7, right? There are no 2 to 7, so I start from 7 up to 8, 7 up to 8, and 1 over 20 dx. You can already taste it. Which one is harder, right? Which one will be harder? This one will be harder. If you use density function, it will be harder because you're going to integrate all these things, right? You're going to integrate all these things. But when you integrate and you evaluate all this, total up everything, you were definitely getting, okay, you were getting 13 over 20. You will get the same answer as this, right? Same answer as this. But which one is faster? This will be faster. Cumulative distribution function will be faster because you can just directly substitute, boop, and you get the answer, right? But this you have to accumulate. If you use density function, you have to accumulate one by one until less than 8. Less than 8 means from -2 up to 8. You have to do that. You have to do integration, right? So I hope you know the difference. All right, I give you another example so that you can see the difference. All right, I give you another case. If you want to find the probability of between -1, right? -1 x And for example, 11, right? 11. So there's probability of x between 11 and -1. So what is the difference when you're using the cumulative distribution function and using density function? So okay, now I show you how to using cumulative distribution function. Cumulative distribution function, very easy one. Okay, cumulative, you just put f11 minus with the lower value f-1, right? It's the same, right? It's the same meaning. So if you have -1 x 11, or maybe probability of -1, there is an equal for -1 but no equal for 11, or there is an equal for 11 but no equal for -1. Either they are two got no equal or equal for continuous random variable, they are all the same meaning, all right? They have all the same probability, all right? So now f11, just take the up value, okay? Any of these, you just take the f11 minus the f-1, all right? But substitute to the correct function is very important. So 11 is between where? 11 is between 7 and 15, right? So it's substitute here. So 11 plus 5 over 20. So you have 16 over 20, right? This one, -1, right? -1, not here. Yes, it's here. -1 is between -2 and 0. So substitute -1 here, right? So 2 plus -1, the x over with 10, all right? So 2 minus with 1, you have 1 over 10, right? So you can calculate this, you multiply by 2, you have 16 over 20, right? 16 over 20 minus with 2 over 20, right? Then you have 16 minus 2, you have 14 over 20, then you have 7 over 10, right? As your probability, 0.7. Alright, so very easy if you're using the cumulative. But how if you're using this, right? You must learn, alright? You must learn, okay? So I'm going to show you how to, if you're using the small fx here. So comparison. So sir try to do so that you have very clear picture about this topic here, okay? You cannot confuse. So now, if you want to find the probability between -1 x and 11, either this or this, or is the same, all right? So this one, then you look at here. You remember when you're using the small letter fx, the probability density function, you have to use integration. You have to use integration. So at first you have to identify where is -1. -1 is here, right? -1 is here. And where is 11? 11 is here. 11 is here, right? So then you have to integrate, start from -1, right? Start from -1. X must be more than -1, means -1 and above, right? -1 up to 0. -1 up to 0. And during this time, it will be 1 over 10 dx. Then you have to add up until you reach 11. -1 start up to 11. So -1 up to 0 is 1 over 10. And now, then 0 to 2. You have to start with 0 up to 2. So 0 up to 2 is 1 over 5. 1 over 5 dx. And later have to continue until you reach the point 11. So means 2 up to 11. 7 up to 11. There is no 2 here, 7, right? So after that, 2 they jump to 7, right? 7 up to 11 is 1 over 20 dx, right? If you add up this, if you're hardworking enough, you go and integrate, blam 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 blam. Okay, blam blam blam. You were getting 7 over 10. The answer will be exactly the same. But I'm going to tell you this will be easier compared to this, right? So you have to understand this. So okay, I already tell you the differences, okay? Differences, so that you're able to understand the difference approach when you're using this to find probability and using cumulative distribution function to find probability. Alright, that's all for this video. Hope it's really helping you.